So let's go ahead and take a look at something called Pascal's triangle and how we can create it. We're going to start off with just a single 1 in our first row. This is what we're going to call the n equals 0 row. The next row will have 2 more 1s. Pretty boring so far. Now, from here on out, once we start with that base there, we're going to go ahead and create the next row by following a pattern. What we're going to do is we're going to take these neighboring numbers in this row, and we're going to add them together to create a new number. 1 and 1 makes 2. And then we're going to add an extra row, an extra 1 on the end of each row. So now that I have this row, I'm going to build the next row by adding these 2 neighboring numbers together. 1 and 2 make 3. 2 and 1 make 3. And adding an extra 1 on the end of the row. I'm going to continue this process as many times as I need. Go ahead and add these neighboring numbers together. 1 and 3 make 4. 3 and 3 make 6. 3 and 1 make 4. And then add an extra row of 1s again on, not an extra row of 1s, an extra 1 on the end of each row. Repeat the pattern again. 1 and 4 make 5. 4 and 6 make 10. 6 and 4 make 10. 4 and 1 make 5. And add an extra 1 on the end of each row. I'll go ahead and try to fit one more in there. I know I didn't quite center that in the board, but I could do one more. 1 and 5 make 6. 5 and 10 make 15. 10 and 10 make 20. 10 and 5 make 15 again. 5 and 1 make 6, and then add an extra 1 on the end of each row. And I can continue this pattern on and on and on and on if I want. There's all kinds of interesting patterns in there if you look at this triangle. There's all kinds of applications where we can use this in mathematics. The binomial theorem is only one of them. Just take a look at it and see if you can notice any patterns, though. I mean, I can see several jumping out at me right away, like just looking down this diagonal, 1, 2, 3, 4, 5, 6, and so on. Looking down the next diagonal, 1, 3, 6, 4, 10, and 15. It went up by 2, it went up by 3, it went up by 4, it went up by 5. There's all kinds of cool patterns in there if you really want to hunt for them. But that's how to create Pascal's triangle. We could create as many rows of it as we need. At this point in time, you might not know what in the world we need this for, but that's coming on later in the lesson. Before I stop here, just a quick reference of the rows. This first one that just has a single 1 in it is the n equals 0 row. This is the row for n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, and n equals 6. Probably one of the common mistakes that cause students to miss these problems is they're not using the right row of numbers here for their coefficients. They want to start with 1, 2, 3, 4. So if they're trying to expand a binomial to the 4th power, a lot of times I'll see students go 1, 2, 3, 4, and they'll use this row of coefficients, and that would be incorrect because this is actually row 0. So it's 0, 1, 2, 3, 4, and they would be needing to use this row of coefficients here. So just be careful with that. Remember, it starts with the n equals 0 row.